What is wrong with this loop?
It's false.
Yeah, it's false. It's a pretest loop. For loops are a pretest just like while. Our starting value must be wrong. Maybe we meant to type 1 rather than 11. But anyways, our condition's false, so it's not going to do a thing. So the next slide is called keeping a running total. And we've actually already been doing this before we hit this slide. A running total is just where you keep a sum as you step through a series of values. Here's an example of keeping a running total of all the values between 0 and 10. This is a summation. And I believe we've already done a summation loop. Let's do another one. So, for int I is equal to 0, I'm going to start at 1 though. If you add 0 to something, then, what does it matter? Keep running while x is less than or equal to 10. Not x, I. I should have used x again. I plus plus. And we're going to do sum plus equals I. Now I haven't declared the sum variable, so that's going to give me an error. And then we could do cout sum of 1 to 10 is followed by that sum, followed by name of line. All right, now I do need to declare that sum. So up here, I'm actually going to make it a double. Not that it's necessary, but just in case it got too large to be in an int, which will happen if we write a factorial loop, we won't get any problems. I heard that. Don't make me tired. No yawning in class. I'm kidding. Here we go. The sum of 1 to 10 is 55. I believe that. There's a formula for calculating the summation and a single multiplication, and I don't remember what it is. But it's about halfway. Anyways, yeah. So that looks good. Now let's do a factorial. This is a summation. It's an example of keeping a running tally. I'm going to skip the factorial. We know how to make a factorial. We would just set that equal to 1 rather than 0, and we would multiply it times I each time. What can you do with a summation once you've got it all done? Well, we could also calculate the average. Double average is equal to sum divided by the numbers. Here we don't really know how many numbers we had in there. We could hard code a 10. It'd be better to actually add a counter to this. Int counter is equal to 0. And then add 1 to our counter each time. That way we have an accurate count, no pun intended, of how many numbers we've added. Could we initialize this inside our for loop? Yes, we could. We could cut this out and put that there. But the reason I didn't do that is because I want that counter to be available to us even once we get out of the for loop. So I declared it above the for loop, just like I did the sum. Some people will do this. They'll declare their variable right in there, and then they'll wonder why it's not working. The reason it's not working is because you have to declare your tally, your accumulator, before your loop. You don't want to just try to recreate it and destroy that variable each time you iterate through the loop. So here's their flowchart for it. Set accumulator to 0. Is there a number to be read? Yes, there is. Read that number, add that number to the accumulator, come back. Are there no more numbers to read? Then we're done. So let's rewrite this program so that it uses a while loop and it lets the user type data in. So this is going to be summation of a series of data the user enters. So let's display a message first telling the user what they're going to do. Enter series of values separated by spaces. Ending in a -1. And we will calculate the average and the sum. Tell you what, rather than making it end in a -1, we will just say enter a series of 10 values. We're going to assume we're doing 10 values. And we're not going to let them get out early with a -1. So, we do know how many pieces of data we have. We could use a for loop for this. It also makes sense to use a do loop in it, or a while loop. We could do it in any of those ways. This one is striking me as a good use of a while loop. Why don't we declare a variable called max? This is the maximum of the numbers. And then we're going to declare a counter, and we're going to start it at 1. Do some stuff while the counter is less than or equal to than the max. What are we going to do? We're going to say enter a number. We don't even need to do that really because we told them what to do already. So I think I'm going to comment that out. And then we're going to let them type in a number. CIN into a number. Now I've got problems already. Sum plus equals what they just typed in. I'm getting red errors. I'm getting underlines. What do I need to do to fix that? Well, I could highlight the cursor over it, but pardon?
Initialize number.
Yeah, I don't even have that variable. So it says number is undefined. Int number. We don't have to initialize it, but we do have to create it. We do have to initialize the sum. We already had a variable up here called sum, so this is going to conflict with that. So instead of calling it sum, I'm going to call it total. All right, now that we have all that, we can calculate the average. Double AVG is equal to the total divided by the number. Now I'm just going to divide it by max. We have 10 numbers, max is equal to 10. Why am I not dividing it by the counter? Because counter will actually equal 11 by the time it gets out of that loop. Why is that? Because that's the exit condition. As long as counter is less than or equal to 10, we keep going. But finally, it adds one more to it. I forgot to increment counter. I do have a problem with this loop. Okay, so one last line inside the code. Counter plus plus. And now we can print out the average and the total. The total is equal to the total. End of line. And the average of the numbers is equal to the average. Let's run this. I have a syntax error and it's not going to run? Is that what you're telling me? Yeah, redefinition. Okay. Counter was already defined. Bah humbug. I'm going to undefine it. There you go. All right, and here we go. Enter a series of 10 values separated by spaces, and we will calculate the average of the sum. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And the average is 55. So again, that looks accurate. Whoops. So this is a summation of a series of data that the user enters. We could also make some code that would allow them to enter as many pieces of data as they wanted and then enter a -1 to quit. The code would look very similar. So we don't need a max, but we still need a counter. Let's just start counter off at equal to 0. And then while true, or do while true, either one of them would work. We're going to tell them enter a number. Why are you giving me grief here? Oh, derp. Okay. That's wrong. That should be C out. Okay. And then C in into our number. Let's reinitialize our values. And let's make it say enter a number or -1 to quit. If they type in a -1, we want to stop right there. So if number is equal to -1, we want to break. That will exit the loop cleanly. We won't do anything else. Otherwise, and we could put an else, but we don't really have to because you know that everything after that is part of what would be in an else. All right, thanks. Come back. Go away. Okay. So we're going to add 1 to our counter because we have one valid piece of data. And we're going to add that number to our total. Total is equal to total plus number. Or just total plus equals number. And again, we're going to calculate the average. Average is equal to total divided by the counter. This time counter is actually accurate. We have a problem here though that if they enter -1 immediately, then counter is equal to 0. We're going to divide by 0. It's going to generate an error. But we're just going to pretend that they're going to always enter at least one piece of data rather than try to fix that. We could fix that with an if statement. If counter greater than 0, do this. C out total equals, followed by the total. And then C out average equals, followed by the average. All right. This is going to be annoying because it's going to keep asking for 10 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But now here we are. Enter a number, -1 to quit. I'm just going to type in 3 numbers. 100, 200, and 300. And the sum of the average of that should be 200. So my next one is going to be a -1. The average is in fact 200, which we would expect the average of 100 to 300 to be. Okay, so we've seen a couple of different tally loops, keeping a running tally. One was just a tally of a series of numbers, like a summation, from 1 to 10. Another, let the user type in a specified number of values. We could even ask the user for how many. You know, that might be nicer than just assuming 10, but I'm not going to modify it. And then lastly, this line of code, this section of code, let the user enter a series of values terminated by a -1. That -1 is called the Sentinel value. It tells it when to stop, so this is known as a Sentinel loop. Sentinel loop is one that is broken when you enter a special value. Anybody need help? Did I type too fast? I know scrolling up and down makes it very hard to follow.
Are we supposed to be typing this?
Well, it might not have hurt. I'm gonna upload this as notes. Do create something for you to type in after this, just so that we can have something to put in an in-class assignment.
So after you get done with this, start typing?
Well, if you've been typing, even better. If you haven't been, yeah, start a program so that we can start typing. So sentinels, we just showed what a sentinel was. There are three essential types of loops, or three ways of terminating a loop. One is if you have a counter. I want to stop at a certain point. That's a counter-based loop. Another is to have a user query. A user query is if you ask the user, do you wish to continue? Y end. And if they type in Y, you repeat the loop. And then the third is a sentinel value. The sentinel loop is one where you let them enter a special data, which means quit. And I've been using -1 all along to mean that. So a sentinel is a value in a list of values that indicates the end of data. Those are values that cannot be confused with a valid value. So like if you're asking for test scores, they probably can't get a test score of -999, so that might be a good sentinel value. And you use that to terminate when the user may not know how many values will be entered. That last program we wrote, you could use it to sum one value, an average one value, or to do 100. So here's our example of a sentinel loop. It just does the same exact thing that ours does. It has a counter named game. It has an input variable called points and an accumulator called total. So you let them type in a series of values, and then as long as they don't type in a -1, you keep adding that on. Now they did not do a break statement with that, but I think a break statement is a cleaner way of doing it because I know I've talked about priming reads. A priming read is when you have to write code in such a way that you have to allow two places for input. Here's one place where we do input before the while statement. That's the priming read so that our while loop will actually work. And here we have it again. I think those are inelegant because you have two places. You have duplicate code. We have this output statement duplicated as well. So I would just do a while true loop and then structure it the way we did. Deciding which loop to use. And we've already mentioned this, our rules of thumb. The do loop is a conditional post-test loop, so you use it when you want to iterate something at least one time. The while loop, okay, well, here we go. The for loop is a pretest loop. You use it when the exact number of iterations is known, when you're going to be going through a range of values. And then you use while loop for every other case. So I would have put this one first, this one second, and then this one third. Nested loops. A nested loop is a loop inside of a loop. Have I not talked about nested loops in here? Feel free to say no. Have I? Okay. Pardon?
I said I think so. I don't know.
I've got one yes. What do you say?
It's a loop with
Yes or no?
Yes.
We've done it. Okay, so a nested loop is just a loop inside of a loop. Here we're going to print a table. We print, it counts from 1 to 3, so it's going to be 3 rows long, And when the column counts from 1 to 3, so it's going to be 3 columns wide, and then it prints out the value of the row times a column. So it's making a simple little multiplication table. And it's going to be really poorly formatted. So this is known as the inner loop. It's inside the outer loop. The inner loop runs, and then once it's done, the outer loop is checked again. So the code inside the inner loop will be repeated a whole bunch of times. If the outer loop repeats itself 3 times, and then the inner loop repeats itself 3 times for every iteration of the outer loop, how many times does this actually happen? You might say 6, but it wouldn't be right. Like if you were going to print a 10 by 10 multiplication table, how many elements are you actually printing out? You're printing out 100. So to calculate the number of times the body of the loop actually work, you multiply the number of iterations. This one is going to go from 1 to 3. This one's going to go from 1 to 3. So you say 3 times 3, it would print out 9 times. So the inner loop repetitions complete sooner than the outer loop, and then the outer loop ticks again once the inner loop is completely done. So the total number of repetitions for the inner loop is the product of the number of repetitions. Product meaning multiplication. Using files for data storage. This is actually a whole other topic in my opinion, and I think it should have been a different chapter. So let me come out here, eyeball what we have done so far as homework is concerned for this chapter. Telephone digit conversion. Okay, so here's what our homework assignment is going to be. I want to use 2 different ways of using a tally. So part A, write a loop that lets the user enter a series of 12 values. Got to just be different, huh? Calculate the sum and the average of the values entered. And then B, write a loop that allows the user to enter a series of values, but the user ends the data with a Sentinel value of -999, like test scores.
So basically like what you just did.
Exactly what I just did, yeah.
Will that be in your notes that you post for class notes?
You didn't type it. No, I'm kidding. Yes, it'll be in the
Okay,
class
I thought
notes.
you were like, shit.
Right. Okay. And then put some verbiage saying what they're supposed to be doing. I actually have an assignment version that, a version of this assignment that's got a little bit more text. But so our example would be 12 test scores. So enter test score 1, and the user types in 100. Enter test score 2, and so on. The user does that all the way out to test score 12. And if they entered 100 each and every time, the total would be, and the average would be 100. So that's just a sample run. And then down here, write a loop that allows the user to enter a series of value. Same thing. Tell them, enter a series of numbers ending with a -999. Nah, I'll let you decide how you want to tell the user what they're doing. You pick that. I would like this one to look kind of like this, but you can pick how you want to present this. And yeah, this is awfully similar to what we just did. But it's not going to be the only homework from the chapter. This will be due, since we have break coming up, don't want to make y'all work through the break, make it due a week from Sunday. All right, that's where the chapter should end, but they didn't do that. So let's go back and look at using files for data storage. So we could use files instead of the keyboard monitor for program input and output. Why would you do that? Well, if you had to type in a resume every single time you wanted to print it, that'd be a real drag. Yeah. And you know games, they let you do a save state. You know, it was really annoying back in the days of the Nintendo when you'd play a game and you didn't have a way to save your data. You know, save your spot. So it became really cool when they, you know, started putting batteries into cartridges that let them actually maintain their save state, you know, so that you could save where Sonic was or whatever. Nowadays, those batteries run out, so if you're a collector of old video games, then, you know, the cartridges aren't as cool as they used to be. But,
Like Nintendo 64s?
yeah. So,
Those things are awesome.
you can use files to save your data. You let them type it in. You let the user type in a series of test scores, and then that is saved there so that later on you can open that up and calculate the average. That lets you keep the data, to retain the data between program runs. So you can type your resume and then save it, and the next time you can come and open it, look at it. So the steps are in general. Open the file, and then use the file. Either read from it or write to it, and then close the file. In order to do file I/O, we have to include, well, at least if we do it in the fashion that the text is showing us, the F-stream header. And then there are different types of files. There are IF streams for reading input. There are OF streams for reading output. And then if you're just going to do both, you do F stream without the I and the O. But we're going to do either IF streams or OF streams. Just remember I for input, O for output. Now we've been using streams all along. Every time we use cout, we were using a stream. Every time we use CIN, we were using a stream. So to write to a file looks very similar. All right, now I want y'all to create a file. I'm actually just going to tag it onto this one so you don't have to start a new file if you've been going on already. But we are going to have to go back and include F-stream up at the top. So go up to the top and do # include F-stream. And I'm kind of tired of having to enter all that data each time I run it, so I'm going to comment out everything we've done so far. I'm going to put a /* up at the beginning of it, and then I'm going to go down and put a */ at the end of it, just so I don't have to keep entering that data over and over. All right, let's write 10 pieces of data to a file. Maybe just 10 numbers in a row. That sounds like a use for what kind of loop? If you know in advance how many numbers in the range, which kind of loop is a good fit for that? Yeah, let's use a for loop. So for int x is equal to 1, keep going while x is less than or equal to 10, x plus plus, and we're going to want to write our data to an output file. Now this is going to give me a syntax error because we haven't opened the file or done anything to set this up. But once we get it all set up, I'm just going to call this fout for output file. And then we're going to write that number out, and we're going to write an endl out. Now when we open that file, we'll see 10 numbers in a row, each on their own line. But we don't have that file open. So that's what we're going to have to do. Sorry, guys. So let's go back and look at the PowerPoint to see how to open a file. Here's how you define your stream objects. If it's an input file, you use the IF stream, but we're going to want an OF stream. So in our code, above that loop, we're going to put an OF stream. So OF stream fout. Also could have made it out file or some other name. But anyways, that creates our object, but the file's not open yet. We haven't told it what file name on the disk to write to. And until the file is opened, we can't use that stream. So this would give us an error if I tried to run it at this point. Or not. I wonder what it wrote to. Okay, anyways, that's very interesting. Is there an error list? Nope. Anyways, this certainly did not write anything out to a file because we never opened a file. So the next slide will show us how to open the file. If you're going to use an out file, you do it like that. You use .open. And in fact, you also use .open for end files. Now when you're opening files, you can specify whether you want the file to be overwritten or not. But we're just going to do it as they're showing it. So we're going to use the .open function on our file name. On our file handle. fout .open. And let's call this, I don't know. What are we going to call it? Not I don't know. That'd be silly. Numbers.txt. Now really, we should check to see if that file exists. What if we gave it a bad path? Like say this machine does not have a Z drive and we typed Z:\\\. That open would actually not work. So we can check to see if it's open. Like this, if fout, instead let's do if not fout, print could not open file. And let's just return out of the code. This is not great programming. I'm just sticking a return there to get us completely out of the program if it couldn't open it. Why is that bad programming? Well, it's not going to even do the system pause. You know what? I'm not going to do that. I'm going to take that return out, and I'm going to put the rest of this in an else. after I have written that stuff, I need to save the file. I need to close the file. Y'all all have probably had the experience of you were editing a file and the computer crashed, and when you came back, the file was gone. And that's because it had not been saved and closed. So we're going to do that. We're going to close the file next. So we do fout.close after our for loop. Now the file is closed. And let's print out a message saying that we're done. Done writing file. Now there's something I don't like about this program, which is that the file name is hard-coded here when it should be stored in a variable. But it's okay for a first effort. Let's run it. It said done writing file. Do I know if it really created the file? No, I really don't, but I'm going to go search for it. I'm going to go to the Windows menu, and where it says search for programs, I'm going to type numbers.txt. Just let it look for it. There, it seemed to find it. Numbers.txt. And open it up, and hopefully it's got all the numbers between 1 and 10, just like we told it to do. Anybody need help correcting syntax errors or still typing? Nobody's waving your hands. I do still see people typing, but you didn't wave your hand, so I'm assuming you're on Snapchat or something.
So this actually creates the file name?
It does create the file if it does not exist. A curiosity would be to determine whether it appends to the file or whether it creates a brand new one each time. So I'm going to change my for loop so that I'll be able to tell. I'm going to make it start at 5 and go to 20 so that the next time I look at it, I'll see either, the numbers 1 to 10 followed by the numbers 5 through 20, or else it'll be completely replaced. So I run it. It says done writing file. I go in my search box. I do numbers.txt. And look at that. It did not preserve the prior data. So it is not opening the file for appending. It is completely blowing away your old file, which is usually fine for this kind of program. It wouldn't be fine for like a Word document to just blow it away each time you save it. And what do I mean by that? Well, nowadays when you save a program, save a file, the disk drives are so fast that it doesn't lickety-split. But back in the old days when you had floppy drives, it might take a couple of seconds to save your data. And if somebody kicked the power switch before your program was done, you've lost everything. It opened the file, it erased it, it started writing some new data out. So in cases like that, what you typically do is you create a backup copy of the original file before you overwrite it. And that way, if it crashes and they open it, at least they still have a backup copy of it. If you want to open that file to do some input with it, it has to exist. So if we use an IF stream rather than an OF stream, if the file does not exist, we're going to get an error. Let's prove that to ourselves. Let's add some code to our same program that uses an IF stream. So IF stream, I'm going to call it FN, FIN. I'm going to do the same thing. fin.open, and I want to open a file called, let's be optimistic and pretend that there's one going to be called, numbers2.txt. There's not one. So that's going to be an error. So we have to check to see if the file is open. If not, we're going to use the exclamation mark to mean not. If not fin, if the file is not open, we're going to print out an error message. Could not open file. else we could do something with it. But I'm not going to even do anything with it yet. I'm just going to put else in here, and I'm going to do an fn.close, pretending that we're done with it. I just want to see that error message. I want to see it say could not open file. Yeah, there it could. Could not open file. Our input file could not be opened. I'm going to change this message a little bit to say could not open input file. It sure would be nice if I could print the file name. But I don't want to do this. Don't type what I'm about to do. Don't do could not open input file numbers2.txt. Why? Because if you changed it here, you'd have to also go and change it here. I want to store that instead in a variable. So I'm going to create a string that has the file name. So above or below the IF string file name is equal to numbers2.txt. And then when I open the file, I'm not going to open up a hard-coded string. I'm going to instead open up whatever is stored in that variable name. And that way, if I can't open it, I will print out the error message. Oops, can't use plus signs in this language. You use the arrows. So here's what I added. I added this line, I modified this line, and then I modified that line. So now when it runs, it should actually tell you the file that it could not open. Yes, and it says could not open input file numbers2.txt. You should store your file name in a variable so that you can do stuff like that. It makes the code a lot easier to change when you decide to change the file. And our output file was actually called numbers.txt. So if we wanted this code to work, we should just actually take that 2 out of that file name, and then it would be able to open it. So the thing to remember from all this is that .open will create the file if it's an OF stream, if it's an output file stream. But if it's an input file stream, .open will not create the file if it does not already exist. So I'm going to add a comment. Will not open file if it already exists. I'm going to scroll up and add a comment to that other open that will say erase file if it already exists. All right, now that we have that file open, we want to do something with it. Maybe we want to read all those numbers back out of it. Here's how you see if the file is open or not. You use that if statement, just like we did. First you call .open on your file object, on your stream, and then you check to see if it's open with the if statement. If not, and then you give it the stream variable name. If, and then you print out an error message. There is another way you could do it, but we're skipping that. They're mentioning it here. So using files. To use files, we just use the arrows, just like we've been doing with the keyboard, the console input and the console output, CIN. So here is how we could read in all the data from the file. Not necessarily how I would do it, but it is perfectly good, and it is in our slides, so we will implement it that way. We're going to use a while loop. We don't know how many numbers are stored in here really, but we're going to do this. While, this is really bad, I don't like doing it this way. While fn into a variable, I think I'm just going to call it n. We have not declared that, so that's going to be an error. above my while loop, I need to declare that variable. Since these are all integers, I'm going to make that an integer. We're going to read in that number, and then we're going to print it out. I just read, followed by the in. Okay, it just read my output file. It opened it, and since I changed that numbers2.txt to just numbers.txt, it actually found a file to open, and that file contained the numbers 5 through 20. We saw that a little earlier. I could look for it again. Numbers.txt, open it up. We see that it has that data, the numbers 5 through 20. If you didn't change those numbers like I did, then yours will still say 1 to 10. Alrighty, everybody get this going. Is it opening and actually reading lines of code? Change that number. What is our file name actually? What's the file that you wrote to up above? If you scroll up here, you'll see that our file name is numbers.txt. It's not that you made that mistake, it's that I made that mistake on purpose and you didn't see me correct it. There we go. Anybody else? We all good? Maybe people too shy to say that they know what to do. If we come up and look, our file is actually called number.txt, so the file that we're in here is that is not your fault. Okay, got the right word. That works. Because I made that mistake on purpose just to give you a message. So this is one loop that'll read in all of the data.
The loop was being correct. I think that may be the one where you purposely messed up.
Right. Yours is not going to print any data because the name of your input file does not match the name of your output file.
I just take this away.
So just take the 2 away. Yeah, just take the 2 away in that numbers2.txt. That'll fix it so that it'll actually run. So this is a for loop. Excuse me, that's a while loop that will read in data. I don't particularly like the way that's structured, so later on when I demo code, I will probably be doing something a little bit different. Why? Because I don't like the input operation being inside the condition of the while loop. This is actually pretty obnoxious. We're doing a whole bunch of stuff right here. This is an input command. And then we're just using that as a condition for our while. If I was going to try to fix this, I'm going to take a stab at it. I'm going to make a Boolean variable called, don't make this change, I'll undo these changes. I'm going to make a Boolean variable called OK. And then I'm going to say OK is equal to, reading that in, like that. And then while we are OK, keep doing that. And it's not liking something about what I've done. Let me see if I can fix this real quickly. Nope. What does it want? Does it want int? No, okay, I'm completely undoing it. There are other ways of structuring it so that the read command is not the conditional for your while loop. For fun, because this is fun, do this. Instead, make that while true, and let's just put that read statement right above it. Now, this is not good code. It's not actually going to work. So we will be undoing this change pretty quickly. But it's stuck on the last element. So it's repeating that loop endlessly. We would need to detect if there's any more data in it. And if there is no more data in it, then bail out. But I am going to go ahead and undo that. I'm putting that fin error arrow in back inside my while loop, in my while condition. This is just saying that older versions of C++, you had to specify your file name like this. We don't have to do that. But if you ever start getting errors from calling .open, it's probably because it's compiling something older than the version of C that was ratified in 2011. Okay, breaking and continuing a loop. We really are at the end of this chapter now. Breaking out of a loop. You can use a break to terminate execution of a loop. Use sparingly, if at all. It makes your code harder to understand and to debug. When used in an inner loop, it terminates that loop to go back to the outer loop. We'll go back and we'll code a nested loop that uses the break statement, and also one that uses the continue statement. The continue statement. You can use the continue statement to go to the end of the loop and to prepare for the next repetition. Also use sparingly. Like break, it can make the program logic hard to follow. On the other hand, I think while true with a break is very easy for y'all to understand, so that's why I keep demonstrating it. But the continue is kind of weird. Let's go ahead and use a nested loop that uses a continue and a break. We're going to need two counters. I think I'll just use for loops. For int x is 1, keep going while x is less than or equal to 6. Add 1 to x each time. And then for int y is equal to 1, y is less than or equal to 6, y plus plus, now I'm going to have some dumb logic. This does not really make sense, but it's going to illustrate it. If x is equal to y, I don't want to do anything else. So I'm just going to issue a continue statement. That was supposed to be y, not 1. If x is equal to y, continue. Don't do it. Skip that number. And then down here, we're going to do if x is equal to 5, then break. This is really convoluted code, and it's kind of illustrating why you don't want to do this. And above that, we need to put some print statements. After that continue statement, I'm going to print out the value of x times y, followed by a space. And I better put the x times the y in a parentheses, I believe. And then before that x is equal to 5, I'm going to print out an end of line. So here's the output from that. That's kind of stupid looking output. Instead of making it print out x times y, just make it print out y. Here we go. Look how it runs. The first time it ran, it did not print out a 1. Why is that? Well, here's our print statement. But what about that if statement before it? X equaled 1 and then y equaled 1. So x was equal to y. So it continued. The continue statement causes it to skip back to the beginning of the loop and iterate again. So it added 1 to y at that point. And then that condition was no longer true. So it printed out 2, 3, 4, 5, and 6. Then it was finally done with that loop, and so it printed out our end of line. Now at that point, x still equaled 1, so it did not break. Then it came back up here. Now x equals 2 because we've added 1 to x. And then the y starts counting again from 1 to 6. Now when y is equal to 1 and x is equal to 2, it's not going to continue, so it's not going to skip that one. So it prints a 1. But then when y is equal to 2 and x equal to 2, it skips it. So that's why there's no 2 on that second line. Then it continues. 3, y counts through 3, 4, 5, 6. When it's finally done, it prints out the end of line, so it goes to the next line. X is still not equal to 5, so it comes back up here to the top, adds 1 to x. Now x equals 3. And it does the same thing again. Y counts from 1 to 6. 1, 2, 3, 4, 5, 6, except it skips the one where y equals x, where y is equal to 3 and x is equal to 3. So it prints out 1, 2, 4, 5, 6. Now that may be as clear as mud. That may not be real clear. Eventually, at the bottom of the loop, when x is equal to 5, it bails out of the loop completely. That's what the break statement does. So that's why it did not print. That's why it printed only 5 lines rather than 6. I want to make one more change to it, forgive me. Above this inner for statement, I want to print out x equals, followed by the value of x, followed by a colon. The reason I want to do that is so that you can see the values of x and y. So somebody tell me that since x was supposed to go from 1 to 6, why it only printed out values of x from 1 to 5? Because it is break. Yeah, when x finally equaled to 5, we bailed out of the loop early with the break statement. We could do the same thing here, but I couldn't think of a good, use of it, so I didn't. Why are we skipping numbers? Why did we skip the 1 here? Why did we skip the 2 on the second line and the 3 on the third line and so on? Yep.
Because that's what continue means, right? Just to skip when the condition's true.
Right. When this condition is true, ignore the rest of the loop and then come back up here. Iterate your variable and get ready to go again. So, kind of a dumb example. We're not going to use continue in here as far as I can think of any examples. But beyond that, I do want you to know how to use break. What I use break mostly for is enter a value or -1 to quit. And if they type in a -1, I issue a break to get out of the loop. It makes the logic cleaner. You don't have to use a priming read in order to start your loop. All right, guys, we've hit the end of the chapter, so I think we ought to go ahead and end the class as well. We already have some homework, so I'm not going to slap a file I/O homework on you as well. I'll give you one next Tuesday. Tell you what, I will post it so that if some slim chance you decide to work furiously over this stuff over the break and you get bored and you want to do a third homework assignment, you can. But I'm not expecting anybody to do that.
What's
Excuse me?
what's the in-class assignment name for this?
Let's make it a name for it. This is going to be called File I/O. So now we're on J. All right, so there it is. J is File I/O. Apparently I forgot to put a due date on I. I will do that promptly. We did that last Thursday. And this one we did today. Alrighty, any questions over the homework? Now that I've talked so much, you don't remember what it was anymore. Feel free to text me. That's the one where we did the two things, I believe. Let's go and look again. I seem to have lost it. But I remember. One was to do the 12 test scores, and the other was to enter a series of digits ended by -999. So I'll recreate that file first. Alrighty, guys. I'll see y'all on Tuesday. Have a cool break. That's because this is outside of a loop, so we can't break anymore. It also looks like we're missing our system pause command. So, but anyways, take this thing, and all three of these lines, actually the easiest thing to do would be to move that brace. This brace right here. Delete that brace and then put it underneath. Completely delete it, yeah. And then just put it down here underneath. And it came back. Yeah, after that break statement.
So just,
Why is there no class on Thursday?
Fall break.
Oh,
alright.
Great.
I fixed that, okay.
Good week, sir.
The one I
You
was
too.
writing, it's gonna open in the file.
And you have to kind of ignore all of that cannot file or open the PDB file. But there must be some mistake, so go ahead and close that. I'm not seeing our error window. Do a build, clean, and then a rebuild, a build, rebuild. Alright, so let's try running it. It's running so fast that we can't see the output. So there's something wrong there, I think, but we need to go ahead and put our system pause command at the bottom again. Do it before that slash though, before that brace. Parentheses, quote, yeah. Quote, semicolon. And now we've got to put our brace back. Cool. All right, let's see what he's doing. Oh, we're not asking for input anymore. That's why it's running so fast. There we go.
Thinking that is right?
Yep, that is correct. All right. Hello?
Can you bring out this code for me, please? Because I missed the first part.
Let's see, this one? Yeah, I'll let you scroll it up and down.
Oh, I turned on my computer, so
Okay, do you need me to print this out?
yes.
Okay, I'll do that.